Okay, so let's continue on and talk about the double angle and half angle formulas. These guys are super important. They get used a bunch. Okay, so let's take a look over here on the right-hand side. These are our double angle formulas. You see, for sine of 2 theta, meaning double angle, right? And if it was, say, 4 theta, you could say that it was 2 thetas. So pretty much any even a multiple of theta will work with this. Okay, you might just have to manipulate it a little bit, but it most definitely will work. Cosine 2 theta, notice this is kind of interesting. There are 3 different iterations for this particular function, and it happens a whole lot, and it's really cool because you can turn a cosine into sines, you know, without necessarily using the Pythagorean theorem. You certainly can get rid of that double angle to a single angle, and that's the whole reason for these double angle formulas. And then finally I have the tangent, and it looks a little bit different than the other ones, but notice that to get rid of the double angle, then you use the single angle in the formula. So let's look over here to the left. I've got us an example here, and it says if sine theta is 3/5 in the quadrant between pi over 2 and pi, which is quadrant 2, which sine is positive in quadrant 2, find sine of 2 theta, cosine of 2 theta, and tan of, oh, I see, I made a mistake here. This should be tan of 2 theta. Sorry. Okay, let's keep on going here. So the first thing I'm going to do is I'm going to draw my little triangle. Get me a little triangle going on here. Here's my theta. My sine is 3 with 5 here, and hopefully by now you've learned that if you've got a 3 as a leg and a 5 as the hypotenuse, it's going to be a 3, 4, 5 triangle. Alright, and then all we're going to do is we're going to apply these formulas here. So when we look at the sine of 2 theta, that's going to equal 2 times the sine of theta times the cosine of theta. So these are all very much plug and chug situations. So that's 2 times, and the sine of theta is going to be 3/5 times the cosine of theta, which is 4/5. So this is going to give us 6 times 4 is 24/25. 25. Said it, did not write it. Okay. Alright, and then let's see, cosine of 2 theta. Now, the truth of the matter is any of these are going to give you the exact same answer. I'm not going to show you that. You can certainly do the work yourself to show that. It's up to you to choose whichever one works for you. In this situation, I'm just going to use this first one. So cosine of 2 theta is equal to cosine squared theta minus sine squared theta. And so that's going to give me my cosine is 4/5 squared minus my sine, which is 3/5 squared. So that's going to give me 16 minus 9/25, which is 15 25ths. Not 15. Goodness gracious. Why is my brain not doing that? 7 25ths. Told you my arithmetic sometimes is really bad, and it's proving to be pretty bad now this time of the day. Okay, and let's look at this tangent. So that's going to be 2 times the tangent of theta over 1 minus the tan squared of theta. So when I plug that in, I'm going to have 2 times our tangent of theta is 3/4 over 1 minus 3/4 squared. Let's go ahead and keep on working that out. So this is 3/2 on top over 1 minus 9/16. Keep on going here. So that's 16 minus 9 over 16, which is 7/16. So we have 3/2 over 7/16. And then we can finish that. And 8, so we have 24 over 7. Okay, so really 1 second of trigonometry and just a whole lot of arithmetic, basically. Okay, so let's take a look at this one. All right, I think I could totally give you a you-do here. It shouldn't take you very much, so let's give you a you-do. You do want to start off by indicating what quadrant this is going to be in. So notice that the secant is positive and the sine is positive. So we're looking for where sine and cosine are both positive. Remember, secant is 1 over cosine. So we want the quadrant where sine and cosine are positive. I'll give you about a minute or 2 minutes. 2 minutes. Okay, so let's go ahead and build our triangle. Now this is secant of theta, secant of alpha is equal to 3. That is actually 3 over 1, right, if we wanted to be technical. And secant is 1 over cosine, so we also know that cosine of alpha is equal to 1/3. So if you don't remember exactly how the secant goes, you can always convert it into something that you work with all the time. So with that being the case, then we get a 1 here and a 3 here, and a 9 minus 1 is 8, so this other side is 2 square roots of 2 because it's the square root of 8. Cool, here we go. Let's do our sine of 2 theta. That's going to be 2 times our sine of theta, which is opposite over hypotenuse, so 2 root 3 over 3, times our cosine, which is the adjacent over the hypotenuse, which is 1/3. So this is going to give us 4 square roots of 3 over 9. All right, and then let's do cosine of 2 theta, and I'll pick another one this time. I'll do the second one there. So this is going to be 1 minus 2 times sine theta, and we see sine theta is 2 root 3 over 3 quantity squared. So this is 1 minus 2 times, and let's clean this up. 4 times 3 is 12. So this is 12 over 3 is 4. So this is 2 times 4. Let me double check that. Over 9. Let me double check that. 4 times 3 is 12. Divided by 3 is 4. Yeah, not over 9. Oh, wait, but it is over 9, so that would be over. Okay, hold on. Darn me. Okay, here, let's do it. So I'm going to come down here and I'm going to do it in a little thought bubble, because obviously I have to explicitly do it today. So that's cool. I'm going to do 2 square roots of 3 cubed quantity squared. So sometimes you just have to do it like this. Oh my goodness. Hold on a moment, please. Okay, sorry about that. All right, so 2 squared is 4 times 3 is 12. I know I had this right. Y'all are probably like, oh my gosh, she had this right. What is her problem? But, yeah. So anyway, so this is going to be 1 minus 2 times 4, which is 1 minus 8, which is negative 7. Okay, and then let's find the tangent, and again I copied and pasted, so this should be 2 theta. So let's get the tangent of 2 theta. That's equal to 2 times the tangent of theta, and the tangent is 2 root 2 over 1. So there we go. Over 1 minus 2 root 2 squared. So this is going to give us 4 square roots of 2 over 1 minus 4 times 2 is 8. So this gives us negative 4 square roots of 2 over 7. It's just a slog. You just got to slog through all that arithmetic. Okay, let's keep on going. Now, I want you to not forget that all of the trig identities that I presented to you thus far in this class can algebraically be manipulated, but I wanted to point out in particular this one, because this one is the one of probably the most powerful and most used, that in the sine 2 theta. But sine 2 theta doesn't have a whole lot of interest. You can't do a whole lot with sine 2 theta, but check out what we can do here. So if we take this iteration here, which is cosine of 2 theta is equal to 1 minus 2 sine squared theta, and we solve for sine squared theta, then we get sine squared theta is equal to, let's see, 1 minus cosine 2 theta, all that stuff, over 2. Which really is a cool way to take something that's squared, especially if you can't factor it. Listen to me. If you can't factor it, you can take something that's squared and bring it down to a non-squared term. Remember, if it's non-squared, you get constants on one side and variables on the other, and it makes it way easier to solve. So that is true, and then also we can, from the same derivation, we can get this. Okay, cool. Just wanted to point that out. All right, so the next thing And I definitely feel like the end of chapter 8 is just plug and chug city. It's just a whole bunch of formulas, and you plug in numbers and you chug out the answers. So here is the half angle formula, and this one's a little bit tricky. It's not terrible, but it's a little bit tricky, and you can see the formulas are given here. Sine of alpha over 2 is equal to plus or minus 1 minus cosine of alpha over 2. Now that plus or minus, to handle that plus or minus, we determine the plus or minus by the quadrant that alpha over 2 is in. Okay, so that's kind of the idea here. Now, there's a couple of tricks here. The main trick is to notice what form we're trying to fit. It has to be an angle divided by 2. And again, remember what we're doing here, because we're dealing in a nice pretty world, is we're only dealing with those angles that we readily know. Okay, so the trick here is to rewrite. So we need to rewrite. Let me find my pen here. All right, so we want to rewrite pi over 12 as something over 2. And it's really straightforward. What we want to do is divide kind of by 2. So just watch what happens here. So we say pi over 12 is equal to, and we take the 12 and we divide it by 2, and whatever the numerator is, it stays, and the new denominator here is going to be 12 divided by 2, which is 6. And so now we can see that alpha is pi over 6. Okay. So if we want to evaluate this, sine of pi over 12, that's equal to the sine of pi over 6 over 2, and this is how you want to write it, because you're looking for that angle on top. You're looking for that alpha, because that's how you can work it from there. Therefore, those alphas have to be those angles that we know. And pi over 12, what quadrant is pi over 12 in? Well, it's in quadrant 1. So here we're going to have a positive, and it's going to be the square root of 1 minus cosine of pi over 6, all that crap over 2. And then when we clean that up, we have the square root of 1 minus the square root of 3 over 2 over 2. We've done this one a couple of times already today. So that is going to be the square root of 2 minus the square root of 3, all that over the quantity of 2. We've done this. And if you don't remember, go back a couple of slides, because we just did a few of these. Okay, so that is what the sine of pi over 12 is equal to, the exact value. I also want to remind you that don't forget that all of these trig identities can also be algebraically manipulated, and so I took the half angles and I squared both sides, and I got these formulas. Okay, so let's take a look at this one here. So we see what we're already accustomed to seeing, which this just prompts us right away to make ourselves a little triangle. This should actually be alpha. I made a typo, and that should be an alpha. So I'm going to write an alpha there. And our cosine says it is -3/5. So the 5 is going to go here. We're going to get a -3 here. And this is in quadrant 3. Now, I don't think I've pointed this out to you before, but in quadrant 3, tangent is positive. And because tangent is positive, if we wanted to add in our positive and negative numbers on our triangle, we would know that this would have to be a -4 because a negative over a negative is a positive, and that's how you would get that positive value there. So anyway, here we go. This is very much a plug and chug situation. I do want to point out one thing. With the tan of alpha over 2, there is a way to avoid having to determine the quadrants by using more sophisticated other formula here, and it is 1 minus cosine alpha over sine alpha. And then interestingly so, this one also will give you the same solution. So basically whatever fits your situation, you could use that and avoid having to decide what quadrant your answer was going to be in. Because when I give you that angle, it's really easy to tell what quadrant it's in. When I don't give you that angle, it's sometimes a little bit more difficult. Okay, so let's do this. All right, so let's take a look at tan of alpha over 2. Now, this would be pretty straightforward. I'm going to just use this first new little iteration of the formula here just because. So I'm going to go 1 minus our cosine alpha over sine alpha. And then I'm going to put in those values. So 1 minus our cosine of alpha is -3/5 over our sine of alpha is -4/5. See how smooth that is if you have those negatives already placed in your triangle? It's pretty nice. So the numerator is 8/5 over the denominator, -4/5, and when we do all the math there, we get -2. Now, when we do the next one, we are going to have to figure out what quadrant the alpha over 2 is in. So let's check out our cosine of alpha over 2. That's equal to plus or minus, we got to figure this out. This part we got to figure out the square root of 1 plus cosine alpha over 2. All right, now to figure out the quadrant, to find what quadrant, I'm sorry, I didn't mean to write pi. Alpha over 2 is in. We take the restriction on alpha and impose the alpha over 2, and I'm going to show you what I mean by that. Okay, so I'm going to write down what we have here. So I'm going to start off with our original, so that's going to be pi less than alpha less than 3 pi over 2. So that's our original restriction. And now what I'm going to do is I'm going to impose a pi over 2, which means I'm going to divide everybody by 2. And so our new quadrant for our alpha over 2 is between pi over 2 and 3 pi over 4. So that is actually quadrant 2, and cosine is negative in quadrant 2. So we're going to go with the negative. All right. So then that's going to equal negative the square root of 1 plus the cosine here. The cosine of alpha here is negative 3/5. All that stuff over 2. So we've got negative square root of 1 minus 3/5 over 2, which equals negative the square root of 2/5 over 2. All right, yeah, that's 2/1. So this is going to be negative the square root of 1/5 when we do the math, which is negative the square root of 5/5. Okay, so the extra piece here is figuring out what that alpha over 2 is, which is really quite simple. It's really quite simple. You're going to just set it up as some pi, so some kind of pi over some kind of number over 2, right? You're just going to, whatever it is, that's how it's going to go, unless the denominator is an odd number. The denominator's an odd number, I don't even know if that'll be anything that'll happen to you, because then it won't be a halved angle if the bottom is an odd number. Hello. Good morning. All right, so let's keep on going here. Oh, we can't keep on going because I had to pause. So I'm going to stop this video now. I'm going to pick back up. I hate that this is in a two-part situation, but unfortunately it is. I absolutely got like 2 phone calls and it just went sideways. So anyway, I had to pause and re-record one of the slides, and that requires me to now end, because it won't let me go on unless I don't know how to do it, but I sure can't figure out how to make it go. It just makes noise at me. So anyway, we will stop here and pick up for part 2. Okay, let's finish this up. All right, so we're talking about double and half angles, right? And here I ask us to use the half angle formula to find the exact value without a calculator. Now, we know that secant is 1 over cosine, right? So we're going to lean into that, and I'm going to write the half angle formula here for the cosine. Okay, just so we can refer back to it. All right, so let's get started here with this problem. The first thing that I'm going to do is I'm going to set it up so that it is in the form of that half angle. Remember, so we're going to have to set it up so it's in this form. And we've got to figure out what number goes on top, and here the number that's going to go on top, the numerator doesn't change, and we divide the denominator by 2, and that is definitely going to work. So our alpha here is 15 pi over 4. Now 15 pi over 4, let's remember that 15 pi over 4 is bigger than 2 pi by a great deal. So next we're going to find the coterminal. We're going to find that coterminal angle by subtracting a value of 2 pi from that 15. So we'll be taking 8 pi away, and so that's going to give us secant of, and I'm going to kind of keep the color coordination going right now. but then I'll drop that here in a minute, but I want you to see that that is just 7 pi over 4. Okay, so we found the coterminal angle. Awesome. Now what we want to do is we want to use the fact that secant is 1 over cosine. So that's equal, this is equal to 1 over the cosine of, and I'm going to 7 pi over 4 divided by 2. You want to leave it in this form so you know what your alpha is. Okay, so now we're going to kind of stray away and we're going to find the cosine of that 7 pi over 4 over 2. Now, we have to determine what quadrant 7 pi over 4 is in. 7 pi over 4 is in quadrant 4, and the cosine in quadrant 4 is positive. So we're cool with that. All right, so it's going to equal the square root of, the positive square root of 1 plus the cosine of 7 pi over 4 over 2. So let's keep on working that out. 1 plus the terminal, the reference angle to 7 pi over 4 is pi over 4, and the cosine of pi over 4 is square root of 2 over 2. All that over 2. So let's keep on going here and getting this all cleaned up here. So this is 2 plus the square root of 2, all that crap over 4, which we can write like this: 1/2 the square root of 2 plus the square root of 2. Now, the reason why I put the 1/2 in front is just so that it's very, very clear that that 2 in the denominator is not underneath the radical. So just to make it very clear, you could have put it over 2. That certainly is acceptable. Okay, so now this is what the cosine of 7 pi over 4 is. So now we're going to flip it back in. So the secant of our 7 pi over 4 divided by 2 is equal to, and I'm going to take this and find its reciprocal, so that's going to be 2 over the square root of 2 plus the square root of 2. All right. Now, we have to rationalize that because we can't have all those square roots in the denominator, of course. And as you're looking at it, you might be like, holy cow. Yes, you're right. We're going to have to do the rationalization twice to get rid of all the square roots on the bottom. So let's go ahead and look at that. So we're going to say, and I'm just going to do this over here on the side, 2 over the square root of 2 plus the square root of 2. The first thing I'm going to do, sorry, it's early. My brain has to work here. First thing I'm going to do is multiply top and bottom by this just to get rid of that outside square root. So that's going to give us 2 square roots of 2 plus the square root of 2. Crazy, right? Over, and we get this guy squared, so that's just 2 plus the square root of 2. So now what we're going to do is we're going to multiply by the conjugate of the denominator. So that's going to be 2 minus the square root of 2. Remember, that's the conjugate. So we can get rid of that square root down there. So now what we're going to have on top is 4 square roots of 2 plus the square root of 2 minus 4, oh, no, sorry, minus 2 square roots of 2. sorry, a little crazy because we have the square root of 2. So we have minus 2 square roots of 2 times the square root of 2 plus the square root of 2. All of that, because it's not a FOIL thing, we're just distributing this big ugly chunk through. Down the bottom here we're FOILing, so we're going to have 4 minus the square root of 2 plus the square root of 2 minus the square root of 2 squared, which those guys cancel, these guys cancel, nothing cancels up here, but we can put them together, and we'll see how here in a minute. And so that's going to equal this on top, 4 square roots of 2 plus the square root of 2 minus 2 square roots of 2 square roots of 2 plus the square root of 2 all over. And what's this denominator going to be? 4 minus 2 is 2. So let's keep on simplifying that. So that means that the numerator is 2 square roots of 2 plus the square root of 2 minus the square root of 2 times square root of, 2 plus the square root of 2. And notice the denominator is gone now. And now we can make this better by factoring out that square root of 2 root 2. And if we take that square root of 2 plus root 2 out, we're left with 2 minus root 2. And so there's our, and we would typically write it this way, 2 minus root 2, in parentheses of course, times the square root of 2 plus the square root of 2. That might be one of the craziest numbers you've probably worked with. But anyway, I wanted to do that problem because simplifying it is a whole lot of business. Okay, so now that means that our secant of 7 pi over 4 divided by 2 is equal to this, 2 minus root 2 times the square root of 2 plus root 2. Nuts, 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 nuts. All right. Okay, let's use the half angle formula to find the exact value without a calculator here for sine. And what I'm going to do is I'm going to give you a little you-do here. And while you're working on that, I'll write over here the formula for the half angle for sine. Okay, and I'll give you about, I don't know, about another minute and a half for you to finish this up. This one should go pretty quick, but there's still a little bit of math to do. Okay, so the trick is to rewrite this in this form. And the way we do that is we take the numerator and it does not change. And the denominator of the original gets divided by 2. Okay, Okay. We also need to note what quadrant alpha over 2 is in, and this is in quadrant 1. 5 pi over 12. 6 pi over 12 would be pi over 2, so this is definitely in quadrant 1. All right. Next thing, we just plug and chug at this point, which is lovely. So this is going to be equal to positive square root of 1 minus the cosine of 5 pi over 6, all divided by 2. Now, the quadrant for 5 pi over 6 is quadrant 2, and the cosine is negative in quadrant 2. And so that doesn't affect the sign outside here. That only affects your actually math on the inside. So this is going to be 1 minus, and this is going to be cosine at pi over 6 is 1/2, so this is going to be square root of 3 over 2, so this is going to be minus square root of 3 over 2. All that divided by 2. And as we clean that up, which you'll get so good at this, hopefully, to where you don't even have to do many of the steps. You definitely want to write your stuff down so you're not screwing up. So this is going to be the square root of 2 plus the square root of 3 all over 2. Or I like to write it like this as well. Okay? All right, cool. Let's see. Let's move on to solving a couple of equations. So here, as soon as you notice those double angles, you should be like going, ooh, I can use that double angle formula. Let me remind you what it is. The double angle formula is sine of 2 theta is equal to 2 times sine theta cosine theta. Okay? So let's apply the rule here. And as we go through for this first part here, we're going to get 2 sine theta cosine theta plus, but this guy is in the form of 2 times 2 theta. So this guy is going to become 2 times the sine of 2 theta cosine of 2 theta equals 0. Okay, now you might be tempted to go, oh, these guys are the same, but they're not, right? They're not the same at all. So I'm going to keep on going here to sine theta cosine theta plus, I need to break these guys up, so I have 2 times sine 2 theta is 2 sine theta cosine theta. Okay, because right now, because they're all thetas doesn't mean they're all the same variable. This is very much single theta is like an x, 2 theta is like a y. We got to do something with that so we can actually do it. But that's one of the other reasons why trig is so powerful. It's because you can do crap like this. Times, in cosine 2 theta, what shall we use? Let's see, what did I do? Oh, even smarter. Okay, so check this out. I went down this whole rabbit hole here. It's feeling unfamiliar, and we can continue. But we also can work a little bit smarter. So I'm not going to erase this. I'm just going to put an X through it and say we can continue like this. But it was getting kind of complicated. When it came to the point that I had to decide what to do with this cosine 2 theta, I was like, that's going to make all this multiplication really ugly. Let me think about another way. And so this is our second attempt. We're going to leave this as sine 2 theta plus, and we're going to make this substitution with the identity up here. And so this is going to be plus 2 sine 2 theta cosine 2 theta. Now, because this is already set equal to 0, we can factor out a sine 2 theta. And this is the smarter way for us to have gone about it. When we take sine 2 theta out, we're left with 1 plus 2 cosine 2 theta equals to 0. And now we have our two factors here. So we have our sine 2 theta equals 0. And we have our 1 plus 2 cosine 2 theta equals 0. Now I want you to, the big thing I want you to walk away from with this particular problem is you can start working a problem in trig in one direction, and if it just gets uglier and uglier, you do need to rethink and see if there's another way you can do this in a more efficient manner. Okay, I was just all excited jumping in there using that formula, but I kind of overused that formula a little bit. Okay, now let's finish it up from here. Now we can apply the specific formulas that we need here. So this is equal to 2 sine theta cosine theta equals 0 if you're so inclined, or you could find the general solution. And get all the answers. Okay. I'm going to stick with this guy. Now I'm going to divide 2 out of both sides, so I literally wind up with sine theta equals 0 and cosine theta equals 0. And sine theta is equal to 0 when theta is all the multiples of pi, so that is 0 and pi and 2 pi, but we don't care about that one. And then that means that the cosine is 0 at the pi over 2's, so that would be pi over 2 and 3 pi over 2. Those are all those special quadrant angles that you can go back to the table for, but you could also just draw a little quick graph. Okay, and then come over here to this one. 1 plus 2 cosine of 2 theta. Now at this point, it does kind of matter which one of the 3 options you have. Let me write the 3 options down real quick so we can talk about it. So for cosine 2 theta, we have the cosine squared theta minus the sine squared theta. Now, I'll be quite honest with you. That one is not really highly used. Now, sometimes you want to use it, but usually it's more in the terms of taking cosines and sines that you can't turn into ones and turning them into that cosine 2 theta, so then you can turn them into just sines or just cosines. So we have, that's one of the options. Our other option is 1 minus 2 sine squared theta. And then the other option is 2 cosine squared theta minus 1. Okay, so those are all of the ways that we can use this particular formula. Does it matter which one we use here? No, not at all. Now, well, I guess it does. We don't want to use this one. This one doesn't help, but either one of these are fine. I'm going to use that third one there, so I'm going to use 1 plus, and be careful of this coefficient that you already have there. Don't forget about that guy. 2 cosine squared theta minus 1 equals 0. So now we got to clean this up. 1 plus 4 cosine squared theta minus 2. Oops, sorry about that. Minus 2 equals 0. So we have 4 cosine squared theta minus 1 equals 0. These guys factor as 2 cosine theta minus 1 and 2 cosine theta plus 1. Over here, so we have theta is equal to, well, hold on. I don't want to skip there. We'll have cosine theta is equal to positive 1/2 and cosine theta is equal to negative 1/2. So it's going to be all of those angles, right? And so here theta is equal to pi over 3. So the next place that it's positive is at 5 pi over 3. And then over here, theta is going to be where it's negative, which is 2 pi over 3 and 4 pi over 3. All right, so all of the solutions I'm going to write up here in the corner are 0, pi over 3, 2 pi over 3, pi, oh, I forgot my pi over 2, sorry. Pi over 2, 2 pi over 3, 4 pi over 3, 3 pi over 2, and 5 pi over, there's pi's in there too, pi, and 3 and 5 pi over 2. Let's make sure we got them all. Goodness, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Got them all. Check. All right. Okay. So here I've got a you-do for you. And I'll remind you again what those cosine double angles are while you're thinking about it here. Give you a couple minutes. Okay, so you have choices here, and the choice is very clear which one you should use. You already have a single angle of cosine, and no way to really get rid of that, so you're going to have to lean into that cosine here. So we're going to go with the 2 cosine squared theta minus 1 equals to cosine theta. And now we have a problem from way before. So 2 cosine squared theta minus cosine theta minus 1 equals 0. This is going to factor. We need negative 2 cosine theta plus 1 cosine theta minus 1 equals 0. We can split this guy in half, factor out a 2 cosine theta, leaving us with a cosine theta minus 1. That's our twin. Write it down again. Plus 1 here, so our two factors are 2 cosine theta plus 1 and cosine theta minus 1 equals 0. So here are our two equations. This one is going to be cosine theta is equal to negative 1/2, and this is going to be cosine theta is equal to 1. Now, if you don't know that readily, where cosine theta is equal to 1, I suggest that you just draw your little quickie graph, and you can see, oh yeah, that's at theta is equal to 0. Okay, and then cosine is equal to negative in quadrant 2, and in quadrant 3, cosine is equal to 1/2. The reference angle is pi over 3. So we'll get that as theta is equal to 2 pi over 3 and 4 pi over 3. So our solutions set here is 0, 2 pi over 3, 4 pi over 3. Okay, let's wind this up with a couple of identities here. Let's take a look at this first one. Now, upon first look, you may be going like, oh, I want to do some stuff here, but take a look at that left-hand side. I'm going to just work with that left-hand side because I noticed that that's the difference in squares. And that's the cosine squared of theta minus the sine squared of theta times the cosine squared of theta plus the sine squared of theta. Well, that right there is all equal to 1. So now we're left with cosine squared theta minus sine squared theta. And that is, as we know from the identity, equal to cosine 2 theta. So that one was an easy one. Let's take a look at this one. Okay. Now this one's one of those situations where I'm going to have to work on the left side and work on the right side because we're dealing with cotans and secants, right? And secant is 1 over cosine and cotan is cosine over sine. So those don't really like match each other. So we're going to have to deal with the left-hand side and deal with the right-hand side. I'm going to work on the right-hand side first. So the right-hand side is our secant v plus 1 over secant v minus 1. And we're going to turn those into sines and cosines. So that's going to be 1 over cosine v plus 1 over 1 over cosine v minus 1. Now the next thing I'm going to do here is put those together. So this is going to be 1 plus cosine v all over v over 1 minus cosine v all over v. And now when we flip those over and everything, we wind up with 1 plus cosine v over 1 minus cosine v. So that's where we are with the right-hand side. So that's where we're going to wind up there. So let's deal with this left-hand side. Well, first off, we know that cotan squared v over 2 is equal to 1 over tan squared of v over 2, right? So in the tangent, which I haven't written down anywhere here, let me just write it down here. So the tangent of alpha over 2 is equal to the square root of, plus or minus, right? But when we're doing this, you always assume plus. The square root of 1 minus cosine v, or cosine alpha. And my brain's on the, over 1 plus cosine alpha. All right, so let me get back here. So this is equal to 1 over, and this is how you have to think about these guys with these squares, like that. All right, so that's cool because that allows us to do this. Square root of our 1 minus cosine alpha over 1 plus cosine alpha squared, and then that gives us this magic, right? And then this is a reciprocal, so it's 1 over, and this is actually equal to 1 plus cosine alpha over 1 minus cosine alpha, because we're going to flip to be 1 over. Okay, and now, as you see, that is equal to that. I don't know why I changed my V's to L. Anyway. Know that this is the case. My brain defaulted here, so I'm just going to change all these guys to V's, because you will probably make the same mistake. Start the problem with one variable and wind up with the variable that you usually use. So it's common. Always go back and take a look. So these guys are true. Awesome. And finally, I have this one last one. And it looks a little bit complicated, but it's really not that complicated. But it is one of those that we need to kind of work with both sides a little bit. In fact, I'm just going to note the fact that the secant 2 theta, I'll just go ahead and write my left-hand side over here. Our secant 2 theta is equal to 1 over cosine of 2 theta. So let's just leave it like that, and then let's work over here on our right-hand side. So on the right-hand side, we have secant squared theta over 2 minus secant squared theta. And because we're dealing with cosines over here, we want to get rid of those secants and definitely kind of turn them into cosines. So this would be cosine theta squared over 2 minus, sorry, that's 1 over cosine theta squared, 1 over cosine theta squared. Now let's clean those up. So that denominator, let me just write a little equal sign here. That denominator right there, I'm going to go ahead and just write this guy still like this. And when I do this guy here, we have 2 minus 1 over cosine squared theta. When we put that together, oh no, I kind of lost my way for a second. I promise you I know where I'm going though. So the numerator is 1 over cosine squared theta. Let's just write it like that for clarity. Over, and when we put these guys together, we get 2 minus, a lot of minus. Put these two together, we've got to do the common denominator and all that. So that's 2 cosine squared theta minus 1 over our cosine squared theta. So that's going to give us, when we flip those over, we wind up with 1 over 2 cosine squared theta. So getting back to where we were here with this 1 over cosine 2 theta, can we set it equal to, and we can. So let me just write it like this. So 1 over cosine 2 theta is definitely equal to, I forgot my minus 1, is definitely equal to this 1 over 2 cosine squared theta minus 1. And how do we know that for sure? Because we can flip them both over, because we know that cosine 2 theta is equal to 2 cosine squared theta minus 1. All right, there was another identity. Okay, we're done. Y'all have a good day.